Energy storage is a critical component for really any sort of renewable energy. So renewable energies by nature are intermittent. You could imagine with solar, you don't always have the sun shining. With wind, maybe the wind isn't always blowing. So energy storage is critical to be able to kind of transfer the power that we're generating at one time or place and translate that to energy or power at another time or place.
The biggest change in batteries over the last 20 years is probably just the scale. The number of batteries that we're currently producing globally is growing very rapidly every year. As we develop more battery systems, get more batteries in vehicles, more batteries in stationary energy storage systems for storing renewable energy, we really need to make sure that those batteries are safe and that they last a long time, and that we recover those valuable resources at the end of those batteries' lifetime.
We're going to need multiple streams of the battery materials in the future. Right now we can't mine enough nickel, cobalt, manganese for all the batteries that are anticipated to have in the future.
NREL is part of the RECELL Consortium, which is a DOE-funded consortium of multiple national labs and universities that's working on trying to develop direct recycling processes that are more energy efficient and low cost and restore the material back to that very pristine, nice state.
A lot of that involves taking a battery, putting it into a safe state, shredding it, separating out all the different components, the cathode, the anode, the separator, the current collectors, recovering the materials of choice, and then basically re-engineering them so that they can put into the batteries of the future.
Here at NREL, we've started with a lot of bench scale process development, and then we're at this critical point where we need to think about how this can scale to actually work in an industrial fashion. I think there's more of a move to incorporate these recycled materials into novel products, and in some cases we're actually looking at ways that rather than just recycling a material as is, we're thinking about how we can jump the gap and actually create a better engineered material from the recycled product that then is kind of even more advanced that can go into next generation batteries.
Industry would want to partner with us because we do the difficult research and development in order to get the processes to the point that they can become economically viable in the future. So NREL and DOE takes the risk of investing in these research and development technologies, and then the industry benefits from that.
What makes NREL unique is actually the breadth of knowledge that we have here. We have a lot of different techniques from modeling and analysis, as well as basic chemistry expertise with regards to end-of-life batteries and how to restore them. We also have a lot of unique ideas that we've been able to work on from the original concept all the way to kind of proving them out and showing different companies and other universities and labs why each of these techniques is worth investigating.
Working at NREL is great because we have a really broad impact on the energy industry in the United States. Everyone from academic groups to small companies to very large companies work with NREL to develop new technologies or learn more about how to electrify mobility, electrify energy storage, and develop new technologies to enable a carbon-free energy economy in the future.